The design phase of software reverse engineering. In this lesson, the refor keylogger software will be taken through the design phase, which in lesson 5 I said it is the stage in the process of software reverse engineering where a structure chart in the form of a flowchart is identified and designed based on the gathered information obtained from a software to be reversed. The structured flowchart of a software enables software reverse engineers to determine the processing details of each model structure in the procedure flowchart using the structured language like a decision table. Also in lesson 5, I did say that the executable program of a software to be reversed is converted into its source code in the design phase. So in this lesson, the refor keylogger software will be converted into its source code. For more detailed explanation about the design phase, refer to lesson 5, that is, the concept and processes involved in software reverse engineering. With our minds refreshed on what the design phase is about, let's now proceed with the conversion of the executable file of the refor keylogger software into its source code. Then later identify and design a structured chart in the form of a flowchart. To begin with the conversion of the executable file of the refor keylogger software into its source code, I'll open the Ghidra disassembling tool. It's important to note that because Ghidra is not installed with a desktop shortcut icon, Ghidra can only be opened by double-clicking the Ghidra run.batch file in the Ghidra installed folder in the Program Files folder, which is located in the Drive C partition. For the sake of better user experience, the easy use of Ghidra, and those who are new to Ghidra disassembling tool, I'll be explaining the various features of the Ghidra disassembling tool in the process of reversing the refor keylogger. By default, the welcome window of Ghidra is this tip of the day dialog box, which provides users with tips and the technical know-how on how to use Ghidra. To those who are new to Ghidra, I advise you to take some time to read through the tips in order to be able to learn how to use Ghidra and to know some of its technicalities. In order to create a new project, click on the File menu tab and choose New Project. By default, the Non-Shared Project option is already chosen. But if in case you would like to share your project with others, you can choose the Shared Project option. But since I'm working alone on this project, I will choose the Non-Shared Project. Then I'll click Next to proceed to the next page of Ghidra project creation. I'll type refor project as my preferred name for this project. You can choose to change the default project save location to your preferred folder location of your choice. But for the purpose of this illustration, I will maintain the default project save location. Click on the Finish button in order to create your new project. With the new project created, click on the green dragon icon in order to launch the code browser. Now click on the File tab on the menu bar and then choose the Import option in order to locate the executable file of the software you intend to reverse, in my case the refor keylogger software. On the screen now is the Import dialog, with its first option indicating the format of the software being imported. The inscription in the Format column, which in our case is Portable Executable, is indicating that the software being imported is designed to operate on a Windows operating system. And if the inscription is Executable Linking Format, then it means that the software being imported is a Linux operating system based software. Since Ghidra have been able to identify the version of the refor keylogger software being imported is designed to be run on a Windows-based operating system, it means Ghidra is indeed an effective and trustworthy disassembling tool. While the inscription in the language column is indicating both the programming language ID and the compiler ID used to design and compile the software being imported. The language colon option appears to be inactive because Ghidra has automatically detected the programming language ID and the compiler ID used in designing the refor keylogger software. But in the case where Ghidra is unable to automatically detect the programming ID and the compiler ID of the software being reversed, Ghidra has a pool of programming language ID and the compiler ID to choose from just by clicking on the three horizontal dot button in the language column. It's important to note that without the detection or the indication of the programming language ID, the OK button would be inactive. So always make sure to choose a programming language if in case Ghidra is unable to detect the programming language ID and the compiler ID used to design the software being imported. The next column, which is the destination folder with the inscription refor project, is indicating the project folder in which the software being imported will be saved. This destination folder is automatically created with the same name as the project name. While the last column, that is the program name, is indicating the name of the software being imported. You can decide to change the default name of the program name to any name of your choice. But for the purpose of this illustration, I'll keep the default name as refor-keylogger.exe. Click the OK button in order to proceed with the importation of the refor keylogger software. On the screen now is an optional prompt to have the software being imported analyzed by Ghidra. For an automatic arrangement and the categorization of the source code of the refor keylogger, I'll click on the Yes button to have the source code of the refor keylogger to be analyzed by Ghidra. The following are the various analysis options Ghidra uses for the analyzation process of a source code. The ability to easily know which analysis option to select or deselect for the analyzation process of a source code depends on the features and the category of software the software being reversed belongs to, which in actual fact is identified during the implementation phase, that is, the gathering of information about the software being reversed. For this reason, I advise you to never skip the implementation phase. From the analysis option table on the screen, Ghidra has automatically selected the core conversation ID option because it has identified some features relating to core conversation, which we can all agree that during the implementation phase, we discovered that the refor keylogger has the ability to capture and record both video and audio conversations of its users and its targets. Note that the analysis options may vary depending on the type of software being analyzed. But if in case you are not sure about the features and the category of software the software you are reversing belongs to, I advise you to select all the analysis options. The fact that Ghidra has been able to select the core conversation ID analysis option, which in actual fact the software being reversed has one of its features associated with core conversations, I will leave the core conversation ID option and all other auto-selected analysis options as my selected options for the analyzation of the refor keylogger software. So I'll click on the analysis button in order to begin the analyzation process of the refor keylogger software. Let us review the importation summary report whilst Ghidra is analyzing the source code of the refor keylogger software at the background. First on the summary report is the name of the project, followed by the modification date, then the name of the software being reversed. The report also shows both the programming language ID and the compiler ID, as well as the least system architecture processor the refor keylogger supports, which is the 32-bit system architecture processor. And since the refor keylogger supports a 32-bit system architecture processor, it's obvious it has little endian as its byte ordering. To those who don't know the meaning of the inscription little endian, it means that the least significant byte of an integer is stored at the lowest address of the integer, while the most significant byte is stored at the highest address for data items in a 32 system architecture processor. Since this is a software reverse engineering class, I presume you should know the difference between a little endian and a big endian. So for this reason, I wouldn't go into details about the difference between a little endian and a big endian. But to those who don't know the difference between a little endian and a big endian, I advise you to research about the difference between little endian and big endian in software engineering. After the endian is the addressing size, which has been identified as 32. Next is the minimum and maximum address found in the source code of the REFOR keylogger software. Listed also is the number of memory blocks, followed by the number of found instructions, the number of found symbols, the number of identified data types, and the number of data type categories found in the source code of the REFOR keylogger. To those who have no idea about what the number of functions, the number of memory blocks, the number of instructions, the number of symbols, the number of data types, and what the number of data types categories represent, I urge you to research about it, since it's a must-know and a basic knowledge in software engineering. Also on this summary report is the name of the compiler and the programming language used to compile and design the REFOR keylogger, that is the Poland Pascal compiler. And since Poland Pascal compiler was used to compile the REFOR keylogger, it's obvious that the REFOR keylogger was coded with the Pascal programming language, meaning you have to be knowledgeable in Pascal programming language in order to be able to review the source code of the REFOR keylogger. Let's end the reviewing of the import summary report here in order to check if the analyzation of the source code of the REFOR keylogger is completed. Upon closing the import summary report, if in case you would like to have a look at the import summary report again, just click on the Help tab on the menu bar and then click on the About REFOR Free Keylogger option. Note that the name may appear different depending on the name of the software executable file being reversed. On the screen now is the summary report of the analyzation of the REFOR keylogger source code, which is implying that the PDB program property file is missing, and as a result, Ghidra had to skip processing of the PDB file. To those who don't know what PDB stands for, PDB is the abbreviation of Program Database and is a proprietary file format developed by Microsoft for storing either a debugging information about a software or a program model such as a dynamic link library files abbreviated as .dll or executable file also abbreviated as .exe. PDB files often have the extension .pdb and are typically created from source files during compilation in order to store a list of all symbols in a model with their addresses and possibly the name of the files and the line on which the symbols are declared. These symbols informations are not stored in the model itself because it requires and takes up a lot of space. You can research more about Microsoft PDB files for more detailed explanation. With the completion of the first objective of this lesson, which is the conversion of the executable file of the REFOR keylogger software, let us now proceed to accomplish the last objective of this lesson, which is to identify and to design a structure chart in the form of a flowchart. Before we identify and design a structure chart from this source code, I would like to bring to your attention that a source code of a software is often copied or cloned in the design phase. That is, if the purpose of reversing the software is to clone or to copy its source code. But if the purpose of reversing a software is to investigate it in order to know how a software has been designed to function, then the source code of the software being reversed ought to be carefully studied in order to identify, design, and to generate a structure flowchart out of it. And since the last objective of this lesson is to identify and to design a structure flowchart based on the functionalities embedded in the source code of the REFOR keylogger, let us proceed to first identify the functionalities embedded in the REFOR keylogger source code. Luckily for us, unlike most of the software disassembling tools, Ghidra has the ability to automatically identify the functionalities in the source code, just as it has automatically identified the functionalities in the REFOR keylogger source code during the analyzation process. and has also proceeded to automatically design a structured flowchart based on its identified functionalities in the REFOR keylogger source code. The identified functionalities, features, and the processes of how the REFOR keylogger works has been mapped in the left panel in the form of a program tree which represents the processes involved in memory mapping of the REFOR keylogger, and has been categorized in the form of a symbol tree which shows the symbols from a program in a hierarchical view, organized by the following categories: externals, function, labels, classes, and namespaces. The root of the symbol tree is the global namespace, where namespaces define a scope such that the symbol names are unique within the namespace. The type of namespaces that Ghidra support are global, external, function, class, and generic namespaces that reside in the global namespace. Note that in software engineering, every namespace has an associated symbol. Now let us exploit Ghidra's auto-identified functionalities in order to compare it with the functionalities we identified while exploring the graphic user interface of the REFOR keylogger during the implementation phase. Click on the function folder listed in the symbol tree panel in order to check out all the functionalities Ghidra discovered in the REFOR keylogger source code. You can choose to click any of the outlined functionalities in order to review that particular function script, which is located in the source code being displayed in the listing display panel, as being displayed on my screen. Due to the large volume of the identified functions embedded in the REFOR keylogger source code, I wouldn't be able to go through all the functions with you, but I am encouraging you to go through all the outline functions Ghidra has identified in the REFOR keylogger source code and compare them with the functions that we discovered through the graphic user interface of the REFOR keylogger during the implementation phase, in order to determine if there may be any hidden functions embedded in the REFOR keylogger software. Let's now switch to the source code of the REFOR keylogger in the listing display panel in order to identify some of its embedded functions. Take a look at the left side of the source code. As I'm scrolling through the source code, you'll notice that there are some arrows indication at the left side of the source code. These arrows are referred to as flow arrows and are there to graphically illustrate the flow of execution within a function. And if you take a careful look at the flow arrows, you'll notice that they are of two different types. One of the type of the flow arrow is made up of dashed lines. The dashed flow arrows are referred to as conditional jumps, while the flow arrows which is made up of solid lines is referred to as unconditional jumps. By default, flow arrows are only shown either at the start or at the end of a visible address. That is why as I scroll through the source code, you'll notice the flow arrows appearing and disappearing just as the addresses embedded in the source code also appears and disappears as I'm scrolling through the source code. You can select an arrow by clicking it with the mouse in order to keep it from disappearing as you scroll through the source code. Note that selected arrows appears in green color as being displayed on my screen. In order to navigate to the endpoint of a flow arrow, simply double-click that particular arrow. And in the case where the cursor happens to be at the endpoint of an address, equally double-click the arrow of that particular address in order to navigate to the start point of the arrow. You can drag the border between the panel displaying the flow arrows and the main code browser panel in order to resize the flow arrows as I am illustrating. To hide the flow arrows, simply drag the border until it's no longer visible. Note that flow arrows automatically disappear themselves when they are no longer visible. Now to the main code browser panel. At a careful look of the source code as I scroll through it, you will notice a plus sign just at the beginning of some of the script. These plus signs are indicating that there are some hidden content of structures and arrays which will be displayed upon clicking on these plus signs. Now let's check out Ghidra's auto-generated structure flowchart, which has been generated from the refor keylogger source code. In order to see Ghidra's auto-designed structure flowchart, just highlight all the source code by pressing the Ctrl key with the A key on the keyboard. And then click on the Display Function Graph button located on the taskbar. On your screen now is Ghidra's auto-designed structure flowchart generated out of the source code of the refor keylogger. In order to see the relationship link and the process flow, just click on any of the structure chart. In order to know how the refor keylogger is designed to operate, and as well as the opportunity to compare the information you gathered in the implementation phase with this auto-designed structured flowchart, in order to determine if indeed the refor keylogger has some hidden functionalities aside its officially outlined functionalities, I urge you to take some time to study this auto-designed structured flowchart generated out of the source code of the refor keylogger by Ghidra. We will review this source code into details in the next lesson, that is, the analysis phase.